So I will post this definitely and ask the rest to look at it, because I see there's about 4 or so not on here. So I would like you to mark this, right, as we go. This is what I mean by self-assessment. So please mark, mark it with a pen, or mark it with a pen, because I would like you guys to still scan this in and submit it on Moodle. Moodle is slightly more stable at this stage, so you can definitely submit it on there. I am not going to post the quiz on Moodle, not as a quiz, but I'm going to do it as a multiple choice paper for you guys. Okay. With all the comments that I saw and heard that you say is that you are still struggling a bit with the isomers. Hopefully after today's lesson, you'll be slightly more in control of it. But as I also said, the multiple choice is extremely challenging, specifically when it comes to the organic chemistry part. Okay? You need to know the work really well. So, and that's why I thought, oh, let's do it then rather as just a multiple choice worksheet for you guys, which is going to count for marks, right? But that there is not that specific time limit. Okay. As you work through that multiple choice, and I'll mention it at the end as well, think about it. You have 1 minute 20 per question, and then you'll see why it is even more challenging than the physics. Okay, so here we go. Let's go through this. Make the corrections as well as you go along. Remember, in the greater scheme of eternity, the mark that you score per worksheet counts everything together. That means the test plus the worksheets counts to about 5 to 10 marks max, right? So please don't let that put you off. It's a learning process. It is not the end of the world if you score close to 0. It's fantastic if you score close to 28 for this worksheet. That would be great. But it's the start of your organic chemistry worksheet, so just bear with me. All right, enough said. Those that could have joined or would have by now. So let's have a look at the next question. So we start with a question where they say you have a molecule with a formula C4H8, right? So immediately, if we look at that, that's the general formula for what? That's the general formula for an alkene. How do we know that? Well, it's CnH2n. This is something that you already knew from Moodle. Bloody Moodle WhatsApp's coming through. That you already know from your IGCSE. So they ask us now to use this alkene, which is butene. We need to draw a pair of positional isomers. What does positional mean? Positional means that we are going to move our double bond. So let's start, and I'm going to do the display formula for this. First, I draw my parent chain. There's 4 carbons in, so it's but 1, 2, 3, 4, and my double bond in there. Now, the only other positional isomer would be this one. And I'm going to complete my structures now. So the one is but 2E, and this is but 1E. Remember, I mentioned that if the name changes, then it is an isomer. Okay. Always complete the picture. If you can count to 4, you can do organic chemistry. That's usually what I say. So 1, 2, 3, and 4. Yeah, 1, 2.
So could you just put the double bond in the last one.
Yeah, absolutely. But just remember, this would be carbon 1. If you put it in the last one, that would be carbon 1. So it doesn't matter which side it is, it's going to be but 1E.
Okay.
All right. So your orientation doesn't matter in this case. So your number 1 could be on the other side if that is what you asked. 1, 2, 3. Oh, do you see I made a mistake now? That's not there. Just ignore that little line over there. I couldn't count. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Okay, so that's our first pair of isomers. Now they say, what about a pair of chain isomers? What does chain refer to? It refers to chain length. So I'm just going to move this slightly up. So again, we're going to have a molecule with 4 carbons in, because there's 4 in there. And then we're going to decrease the chain length to 3. The only other place where a carbon can be is as a methyl group over there. Right? Let's keep my double bond between carbon number 1 and 2. And remember, my double bond as a functional group takes preference. So that's carbon number 1, that's carbon number 2. That's carbon number 1, that's carbon number 2, carbon number 3. I'm just numbering it like this because then you guys can see what is happening. All right? So listen, guys, I'm just going to quickly, just excuse me for 1 minute. I'm going to put the mute on here. I apologize. There's just an emergency that I need.
Hang on, what, guys? What's a pair of chain isomers?
Exactly what you drew.
Yeah, but what is it?
It's when you branch the chain, so you change the shape of the chain, basically.
Okay, but the first one isn't then, because the first one stays straight.
But it's an isomer, which means this chain is just linear and this chain is branched.
So could you also do but2ene?
No.
Use that one.
Well, yeah, no, you can. You could, but not for the second, not for the second isomer.
Because why not? I'm just asking.
Because the shape of the chain has to change. Look, if you have a linear chain, then you have to have a branched chain as your second isomer. Otherwise, they're not isomers.
Okay. And like, how does it matter where you put the double bond in that? Does it matter where you put it in a branched chain?
No, I don't think so, no.
Okay.
Leon, you asked a good question. So listen, there's no other position where it could be, right? So because if you just bend it, you can't do this. Let me show you quickly. If you have that as your straight chain, for instance, you can't do that. Do you understand? Because then all that you did is you bend the chain, then you're still with 4 carbons in your longest chain. Either could you put it on the other side, because then it would be carbon, carbon. So for this specific chain, the only option to branch it was to put it there. And that's the middle of the chain. Okay. Should you have a longer chain, let's say you have how many carbons? 2, 4, 5 in there. Then it doesn't matter. You can put a carbon in there, or you can put a carbon in there, for instance. Right? Depending on how you number it, should you have put it in there, it would give the same name as that carbon. So that's the thing that you need to look out for, and that's why you need to know the name as well.
So in order to be safe, always put it in the middle.
start putting it in the middle. Yeah, that's a safe option. Because let's name these two molecules quickly. Let's name them. What's my first one? Well, that's similar to that. It's but-1-ene. But-1-ene. What's the name of the second molecule? Anyway. Yeah.
Prop-1-ene.
Yep. 2-methyl prop-1-ene. Right? Give the structures and full names of, okay, sorry. Everyone okay with that naming in there? Is Daniel in here? Because Daniel, you asked about naming yesterday.
Hang on. So why
Yeah.
does the first carbon have 3 hydrogens?
Yeah, it doesn't.
If it's got a double bond as well.
Yeah, it doesn't. You see, I'm not concentrating because my mind was now at other places with apologies. Right? But thanks for picking that up. You need to just cooey me this morning as well. All right. So good. Always count, must have 4 bonds, no more. Right? Can't have less either. Right. Stereoisomers. What are stereoisomers? What are stereoisomers?
When
Yes.
compounds have the same molecular formula but a different arrangement of atoms in space.
Right. Okay. So they are different in the spatial orientation towards each other. Now, if we sit with a double bond, what are we going to deal with? Is it going to be optical or is it going to be geometric? Geometric? Yes, absolutely. It's going to be cis and trans. And remember, you can only have a cis and trans around a double bond because it limits your rotation. So you're going to have your double bond in there. The only one that can exhibit cis trans is my but-2-ene. Why not but-1-ene? Anyone? We dealt with it in class, those of you who attended that class.
No idea.
The double bond is in the middle, so.
When it's in the middle, there is
The
cis trans
rotation
isomer.
thing.
But when it's between carbon number 1 and 2, it's 2 of, or the same group, 2 similar groups, exactly the same groups attached to my carbon. So there's no distinguishing between it, so it cannot exhibit it. So if we're looking for cis trans, it is with reference, for instance, to the rest of my chain, my methyl, in this case, CH3. So being trans across my double bond, and on the same side of my double bond. So this would be cis but-2-ene. This is trans but-2-ene. Right? So again, this is about the reference point. Is that group and this group lies across my double bond. While in my cis, it lies on the same side of my double bond. And because my rotation is limited, cannot rotate around, those carbons cannot freely rotate around my double bond, that molecule is fixed. Same with this one. And that's why it's referred to as stereoisomers. All right? Questions on that?
Yes.
Okay.
Do they have to? Do they have to be opposite to each other?
Yes, that's the whole idea of being trans and cis.
And what if they're not opposite to each other?
How do you mean not opposite to each other?
Now say they're both on the same side and everything.
Right, so
Like in the second one.
you mean something like that.
Yeah.
Can't.
Yeah, like that.
Right? So again, can't, because similar groups. So which side is which side now? You see. So any time that you have a one-ene is never going to show you that rotation because it's got the hydrogen and hydrogen in there. The only time that it could potentially have that when there is a halogen attached there and a halogen. So there must be two different groups attached to that carbon and two different groups attached to that carbon to show stereoisomerism.
Okay. So they have to be, okay, yeah.
Must be different.
And if it's not like that, it's wrong, right?
That's it. And it's wrong. Right. Let's move on to my second page. And now I understood that this top question totally got some of you. We still sit with a C4H8. And I think this is one specific case where I said in class, though, remember, this is a functional group isomerism because my cycloalkane, and this is cyclobutane, is going to be an isomer of an alkene. Right, so in this case, and I'm going to choose in just the one that we just used, butene. I'm just filling in my picture with my.
Wait, sir, could we have used but1ene?
Yes, definitely.
Okay.
Definitely, you could have used but1ene. So both of those would be correct, but1ene or but2ene. You could have used one of the other chain length isomers of the 2-methyl prop 1ene as well. You could have used that as well, because it still shows that it has that molecular formula. That's a double bond. These are single bonds, so therefore functional group. Now, XE 101, how do we distinguish between an alkene and an alkane?
Bromine water test.
It's bromine water.
It's bromine water, right? It's bromine water. So it's the test with bromine water. For your alkane, you need UV light. But with my alkene, that is a spontaneous reaction. So as you add the bromine water, it decolorizes and becomes a clear liquid. So that's your test. That's what you needed to write down in that case. Right. Happy? Let's
Sir,
look
can you
at.
please repeat that?
Yes, definitely. Right. So
Could we just
test
mention
with.
the bromine water test, or did we have to include the UV light thing?
Did you get that?
Excuse me?
Did you get that?
Not really.
Okay. So bromine water, or the test for bromine water, by adding your alkene will spontaneously decolorize it, forming a clear liquid, while your cyclobutane will not. Cyclobutane needs the UV light. Remember what we did?
Yeah. Okay.
Okay.
But did we have to mention the UV light, or could we just say
No.
color?
You just needed to mention the bromine water decolorizes with my butene, but not with my cyclobutane. That's all.
Okay, thank you.
All right. Okay. Definitions. Guys, definitions again in AS, this should be full mark for you. What is the definition for stereoisomerisms? Stereoisomerisms have the same molecular formula but different spatial arrangement patterns. Right? Nice one.
So
Yes.
could you say they have the same structural formula, or should I say the same molecular formula?
Same molecular formula, but same molecular. Keep to same molecular, please.
Okay.
Right. What about a chiral center? What is a chiral center? Hello?
Is it an atom that has 4 different groups bonded to it?
Yes. As simple as that, right? So a chiral center is a carbon atom connected to 4 different groups. Hey, what happened there? There we go. Right, and then something slightly different. A nice 4-mark question. They say, give the structures of 4 structural isomers of C4H9Br and identify each as a primary, secondary, or tertiary. Right. So let's first deal with the 4 structural isomers, and then we can do the identity of it as primary, secondary, and tertiary. Right. So let's deal with that second. Then you will see also what is a primary, secondary, and tertiary for those who did not go and look at it or look at my picture that I sent through, I don't know, yesterday, I think, or something like that. So what would be the easiest structure for C4H9Br? I believe
1-bromobutene with
yes. 1, 2, 3, 4. 4 carbons. There's my bromo and H. H. I think it is well worth it to name the molecule as you said. So let's do that. So 1-bromo butane. But referring to 4 carbons and only single bonds, and there is on carbon number 1, there's a bromo. Right. What else? What can there be? What could be a second isomer of that? How about moving? So
Can't you
position.
just put the bromine molecule in the middle or so?
Yeah.
On the
let's do
second.
the second carbon. So let's do that. 1, 2, 3, 4. So there's my bromo. And let's fill in my hydrogens. And now you already have the name of this one, right? So 2-bromo. And suddenly you have 2 out of 4 already, without even bothering the scorers. Right. So
Would that be a secondary?
yep, but we'll deal with it now. You're absolutely right.
Okay.
So the question also but strangely asked, because it asked actually that bromo, is it attached to a primary carbon, a secondary, or a tertiary carbon? That's actually what the question asked. Right. Let's look at a third isomer. What can happen now? Is it possible to move my bromine still up and down to get a different isomer?
Can we branch?
We can have
and then
a branch. I was about to say
Yeah,
the same
the
thing.
only thing is we can branch it. We can branch it. So let's do that then. So instead of 4 carbons in my longest chain, there's 3 carbons, and we put a carbon in there, right? And this is the only other structure that we can have. So we can't branch it more than that. I'm just going to fill in. Where do you want my bromide on this one?
the middle carbon.
Okay, so let's put my bromide there, and we fill in the hydrogens. So what's the name of this molecule that we just drew?
2-bromo, no, 2-bromo, What do you call that? CH3.
Oh, that's a mess.
That's all.
Two bromo, 2 methyl,
Yep.
3, which would be
Oh,
not wood, but propane.
did you do a lot of naming in your IGCSE?
Not the IUPAC naming, just the basic naming.
What's basic naming? I don't know.
Like you,
We did beat
like
and that stuff, but not this long stuff.
yeah, like you don't use the numbers. It's just a and then the prefix and the suffix. All you learn.
Interesting. Okay, we'll try and fix that in future years. You need to name molecules. That's easy. Right. Let's draw the the fourth isomer. What can happen still? We've exhausted our 4 carbon options. We can't branch it anymore. What can we do?
Could we not make another shape,
And the shape, like how?
like an L shape with a carbon arrangement?
No, then we
A
just
cyclo. A cyclo.
No, we can't. If we do cyclo, we lose 2 hydrogens. Then it's no longer a structural isomer.
Aye.
Aye, yes. What
A
about
T
just
shape?
a T shape?
Yeah, like 3 carbons, and then 1 carbon at the bottom of it.
Ooh, something like that. Do you see my longest chain?
Yeah, like 1. Yeah,
Then it's still deep.
yeah.
1, 2, 3, 4. So it's still a
4. Yeah, that's what I mean.
yeah. Then it's still the same as one of the top ones in there. So that's not very good.
Okay. But if the bromine is on a different place as the first one, then I
Yes.
still have 2 different ones.
That's what we
Okay.
can do. So we can do that. So keeping that structure, but just shifting my bromine to one of these. Running out of space. So now, look at what happens if we write the name for that. It becomes what? A 1 bromo 2 methyl propane. And now the name is different, so it's structural isomer, same amount of hydrogens, carbons, and bromides. So there are my 4 structural isomers. How do I distinguish between primary, secondary, and tertiary? Right? Just have a look at this. It's about the carbon atom. So if a carbon is attached to only one other carbon, that carbon is primary.
So we don't have any primary here in this case.
No, I'll get back to the question per se now. If we have a carbon attached to 2 other carbons, that carbon is a secondary carbon. And if we have a carbon attached to 3 other carbons, that carbon is known as a tertiary carbon. So now, question was, to which carbon is that bromine bonded? So in my first case, that carbon, what type of carbon is it? Is it a primary, secondary, or tertiary?
Primary.
It's a primary. Do you see that carbon?
Secondary.
Hey, that carbon is only connected to one other carbon. So it's focusing on this carbon. That carbon is connected to one other, so therefore that carbon is known as a primary carbon.
But wouldn't you say the carbon in the middle is tertiary then?
Hold on. Look at this carbon. That carbon to which my bromine is bonded, do you see it's connected to 2 other carbons? So then it must be what?
Secondary.
It must be a secondary carbon. In this case, that bromine is attached to this carbon. So this carbon is connected to 1, 2, 3 other carbons. What is it? The primary, secondary, or tertiary carbon?
Tertiary.
Tertiary. This carbon, looking to which bromine is bonded, to how many other carbons is this carbon bonded? It's bonded to a bromine, hydrogen, hydrogen, and only to one other carbon, therefore primary.
Primary. Yeah.
Primary. Right, so that
So
is
for
what the
this
question.
one
Yes,
a bit differently. Can I send you a picture of how I drew it?
yes, you
Because I
do.
don't know what.
Yep.
Yeah, I
You-
also have a different shape compared to all of those. I don't know if it's correct.
Right, but listen, this is why I want you guys to submit your papers at the end as well, man. Right, so please, you can definitely send it to me and I'll comment on that. But I want papers in at the end as well, or during the day.
And sir,
Yes.
what if you like only answer like a few questions, but now we're just like filling it out?
That's fine. I still need that from you, please. Then I can see where you are. And it's about what is on your page. You know, the way that you write it tells me quite a bit. And it tells me, well, did you rush through it? Did you actually work at it? Is there something you're not understanding? And so forth. Right? So questions are good.
Yeah.
Fill it in as we go along and mark it right in next to it a 0 if you didn't fill in anything, or a 1 or a 2 as we talk about it. Right. Guys, if our time runs out, I'm going to start a second meeting so we finish this worksheet, right? Quickly looking at what we can do. That is tertiary, and this is yeah, that's still a primary. That's fine. Okay, I'll look at all of them later on. So you just bend your chain. Be careful of bending it because it might just lead to naming it incorrect if you have to give the name. Okay, but I'll look at all of those as we continue. Let's see how far we get with this. Okay, I'm not taking this page too far away because now they say name the isomer from that C4H9Br that contains a chiral center and draw the three-dimensional structures of the two optical isomers. Right? So coming back to this, which one of these 4 isomers contains a chiral center?
2-bromobutane.
2-bromobutane. Yes, that carbon over there is a chiral center.
Yeah.
Yeah, look at it. It's got a hydrogen attached to it. It's got a methyl group attached to it. It's got a bromine. And it's got an ethyl group. Okay? So 4 different groups. Okay. Right. Let's draw the structure then now. So now we can just write the name in for reference sake. So 2-bromobutane. 2-bromobutane. How do we draw our structures? Right. Let's start with the first one. Remember, there's a group up and a group in the same plane. Then there is a group coming to the front, and there is a group going to the back. Our mirror image, we're going to draw as the mirror image. Look at where my lines are. You see, the only thing that
Exactly correct.
is different is that my dotted line and dotted line shows towards each other. That means they are not superimposable. This is the easiest way that I can teach you to draw it. So they mustn't be superimposable, they must be mirror images. Right, let's write in the groups. I'm going to start.
No, so
Yes.
should the two dotted lines point to each other?
Yes, they should, because then what superimposable mean is if I take this and draw it across this, it should fit, and it shouldn't fit. Look at it, my thumb not fitting, and that's why this is the easiest way to draw it. Look at what your group attached to a specific bond stay the same. So I'm going to keep my, I just need to make sure I have that hydrogen. I keep my methyl group, PH3, CH3, and then you can write it out as this. I'm going to give you two ways to do it. So CH2, CH3, you can keep it like that. Or you can say C2H5. So that and that is exactly the same thing. All right.
So can must the hydrogen be connected to that line, or can it be at the bottom?
Your groups could be different. You could have hydrogen at the bottom and the bromine over here, but just make sure that this molecule is then connected the same way.
Okay.
So your could look differently, but just make sure that whatever is connected to the dotted line going inwards is the same. Whatever is connected to your solid thick line is the same group. Same group and the same group. Then you're making it easier for me to mark and easier for you. Otherwise, I need to go and build